Okay, so we are going to look at the use of the distributive property over addition. And the equation that I gave you was 3 times 5 plus 4 equals 3 times 5 plus 3 times 4. And I asked you to record some things that you noticed about the equation before you started watching the video. So I have some things you may have noticed. You might have something completely different. You might have all the same things, none of the same things. That's not important. It's important that you analyze or examine the equation before you start trying to do anything with it. So let's look at what we might have noticed. There are 3's on both sides of the equation. There's a 4 and a 5 on both sides of the equation. The left side of the equation uses multiplication, or you might have said it has 2 factors. The right side of the equation uses addition, or you could have said it has 2 addends. And both sides of the equation use multiplication and addition. So is this equation true? Meaning, do both sides equal the same thing? So we're going to do some evaluation. On your notes page, there is space for you to record as we go through this. We're going to look at the left side first. So you were given 3 times 5 plus 4. I went ahead and added the 5 and the 4 because I can do that. They're both numbers, whole numbers. So that gives us 3 times 9, and we know 3 times 9 is 27. So then if we look at the right side of the equation, we were given 3 times 5 plus 3 times 4. Well, I know 3 times 5 is 15, 3 times 4 is 12, and then if I add 15 to 12, I get 27. So we can very easily see that this equation is true because both sides have a value of 27. But how does this property work exactly? So we know that multiplication is repeated addition. We also know that multiplication can be represented in an array or an area model. So if I look at that left side where we had 3 times 9, you can see with repeated addition, I'm just adding the 3 to itself 9 times. So we can multiply to get 3 and 9, or we can multiply 3 and 9 to get 27, or we can add 3 to itself 9 times. You could add 9 to itself 3 times. And that works because of, if you look at the area model down at the bottom, we have 3 rows and we have 9 columns. So if we skip count by 3's, we'll get to 27. Skip count by 9's, we get to 27. If we count all the blocks, we get to 27. So if we look at both sides of the equation, we can see that they're equal because of that repeated addition. So I looked at the 5 plus 4, and I actually wrote 5 plus 4 3 times. And then I simplified to 9 plus 9 plus 9. Or we can look at it as the 3 times 9, which we did previously. And there's 9 plus 9 plus 9, or the 3 added to itself. When we look at the right side, we have the 3 times 5 plus 3 times 4. So I looked at it as 5 plus 5 plus 5 plus 4 plus 4 plus 4. And then you could go ahead and say, well, 5 plus 5 plus 5 is 15, and 4 plus 4 plus 4 is 12, and that's similar to what we did on the previous screen. Or you could say, well, if I add the 5 and the 4, I get 9, and another 5 and a 4, I get 9. The third 5 and a 4, I get 9. Or you can take the 3, add it to itself 5 times, and add it to itself 4 times. And this is how the distributive property over addition works. We distribute or multiply the 3 to both the 5 and the 4 because it's going to be the same thing as repeatedly adding. So looking at an array model of the distributive property, you can see in the top part of the array we have a blue section and a reddish section. So we did the 3 times 5 blocks and the 3 times 4 blocks. So if we added the rows together with the 5 and the 4, or the columns together rather with the 5 and the 4, we'd have that 9 again. And 3 times 9 is the same thing as looking at the bottom array where you have 3 times 5, which is your 15 blue blocks, and then we add the 3 times 4, which is the 12 red blocks. Both of them are equivalent. So distributive property over addition Again, we're distributing the 3, this is one of the factors, to the 5 and the 4, which is actually the other factor, and it's equivalent or the same because it's the same picture when we use the array model. So we know that multiplication is repeated addition, and it can be represented in an array. However, just as using multiplication itself is more efficient, so 3 times 9 equals 27 is more efficient than repeated addition or drawing a picture. Using the distributive property is also more efficient once we understand how it works, especially in certain circumstances that we're going to look at next. So distributive property works the same way no matter what kind of numbers we use, and it works even if we don't use actual numbers. So what happens if we have a decimal? Given this expression, 4 times 5/10 plus 2. That would be equal to 4 times 5/10 plus 4 times 2. Well, here's what it looks like as repeated addition. I took the 5/10 and added it to itself 4 times. Took the 2 and added it to itself 4 times. And when I add the 5/10 together, I get 2. When I add the 2's together, we get 8, which is 10. Or more efficiently, if we think of 4 times 5/10 as 4 times a half, so what is half of 4? Well, that's 2. And then 4 times 2 is 8. There's your 2 plus 8, which is equal to 10. So what happens if we have a variable or a letter in the expression or equation? So this one is 4 times x plus 5. So 4 times x plus 4 times 5. And here's what it looks like as repeated addition. Or more efficiently, 4 times x is 4x and 4 times 5 is 20. Now, a common mistake that I see my kids making is trying to add the 4x plus 20. And I often will see, well, that's 24x. But we really can't add the 4x to the 20. And I know it says 5 there. That's a mistake. It should say 20. Why not? Well, because 4x means 4 times x. And since we don't know what the value of the x is, we can't multiply it together. So we just leave it as 4x plus 20. There's one more thing. We can also distribute with negative numbers. So what happens when the factor is negative? Negative 3 times 2 plus 4. We're going to distribute that negative 3. We get negative 3 times 2 plus negative 3 times 4. So with the repeated addition, I chose to show it as negative 3 plus negative 3. That's twice. Plus negative 3 plus negative 3 plus negative 3 plus negative 3. That's 4 times. And I know that when I'm adding all negatives together, it stays negative. You can also see that 4 plus 2 is 6. So this is negative 3 6 times, which is negative 24. It works the same way when it looks like subtraction. So here's a 5 times 1 minus 3. So I can distribute this 5 to 5 times 1 plus 5 times negative 3, or I could do 5 times 1 minus 5 times 3. When we look at that, we get 5 plus negative 15, or 5 minus 15. Both of those are equal to negative 10. So this is the end of the video. There is a half sheet with 4 problems on it for you to work on. When you are finished with this, please turn it in, and if you have any questions, please ask.